That's part of the code concurrency issues, and that's a totally separate issue in performance tuning. I presented things about that at Odoo XP a couple of years ago. It's still valid. You may want to check the recordings of these. I can answer questions about that, but that's not the main topic here. A first analysis of these, how can you know what is causing your Odoo to be slow? Well, it depends on what the end users are going to tell you, okay? And I came up with 4 different kind of messages. First, it's slow all the time, everywhere, whatever I do. Okay, and this can be a platform issue or a database server tuning or an instance tuning symptom. It can be slow for all actions, but not all the time. Sometimes it's fast and sometimes it's super slow. Okay, this can be platform issue or instance tuning, rarely a database server, and you will want to monitor things. It can be slow for specific actions and intermittently. These are typically concurrency issues, okay, because Odoo, in that case, will retry serving the request after a delay, and the action itself is pretty short, but it's being tried, and then there's a sleep and a retry, and there can be locks, okay, and that's a concurrency issue. You can see that in the instance logs. And finally, it's slow all the time on specific actions, and that's the core of this talk, okay, and this means that you have slow code, okay, or slow, inefficient SQL queries in your modules, okay. And then you have the diagnosis tools that you can use, okay, which are platform monitoring for system issues. The instance logs will give you lots of information about what's happening in your instance. And for slow code, there is the instance profiling, which is a super nice tool available in Odoo 15 and above. Okay, because as always, what you want to do is measure. You can't speed up things if you have not measured how slow they are. And sometimes it's quite slow. Your first tool for, doing that, you want to measure, the HTTP request response time. The overall usability things we have for websites, normal websites, they need response time for HTTP requests in under 200 milliseconds or something like that. For an ERP, there will be many actions which require transactional things happening in database. Okay, if you're delivering a delivery order, processing a delivery order, you will have many lines, there will be many actions, 200 milliseconds. That would be super nice, but we all know that it's going to be super hard to achieve for anything with a significant number of stock moves. But if you aim for 1 second for most of your HTTP requests, you're going to be quite good, in my opinion. There are things which are going to be slower, okay, the dashboards, the PDF generations. These are slow because there are external processes involved. There are many HTTP or SQL queries being performed. And you can get information about that from various places. Okay, the web browser, that's super easy to do. Okay, you can teach key users at your customer to use the developer tools of their web browser and to get you an HAR file. That's a HTTP archive, which is basically a recording of what they are doing on Odoo. And then you can analyze the transactions and get first-hand knowledge about what they did and what took time. You can get from the server side, from your hosting side, information from the reverse proxy logs, because you probably have a reverse proxy somewhere, if only to handle the SSL certificate. You will get information about the response time in there, and you will get also in the URL path some information about what was happening, what model were being accessed. But my favorite is the werkzeug logs in Odoo at info level, because these give you more information than the others. Okay, it looks like this. So that's the normal format of the log. You may have different formatting engine set up, but this information for werkzeug, you have this information after the HTTP response has been sent back to the end user. So if things crashed, you won't get these answers. If your process was killed because it consumed too much memory, you won't get that answer, of course. But the interesting digits are the last three, okay, over there. The first one, which is displayed here in orange for highlighting, is the number of SQL queries performed to process that HTTP request. Okay, second one is the time spent in the processing of these SQL queries. And the third time is the time spent in the Python code. Okay, so it's basically the overall time spent processing the HTTP request minus the SQL time. So the overall time spent is the sum of the two. So on the first line, we spent 1.5 or 6.3 seconds. Yep.
The second number is the collective time of all SQL statements that are being executed, yeah?
Yep.
If you can repeat the question for the record.
Yep, so the question is, second number is the total time, aggregated time of all the SQL queries. So for instance, the 201 SQL queries of the first line took overall 0.048 seconds. Yep.
If you refresh if you make the query a second time,
yep,
you will have a lower value because there is cache mechanism, or no?
it depends. If it's a different worker serving and it doesn't have a hot cache, you will have maybe the same number of.
But it's possible.
It's possible, yes.
Thanks.
Typically, you will get the same number, however. No, because there's been a transaction. There's been a commit. So most of the information, except the one which is cached with ORM cache, has to be reread. All the record sets have to be reread after a commit.
If it's just a get of a tree view, for example, there is no.
There is. There is.
Transaction.
Yes. So, what can you tell with these numbers? Typical count of SQL queries is between 10 and 150, something like that. Okay, 100 requests, and you can see the impact of the network latency between your Odoo server and your SQL server. If it's 1 millisecond, you have already 1/10 of a second spent just in the communication between Odoo and the server. If you have a low request count and a high time spent in SQL, it means that you probably have inefficient SQL queries or very complex SQL queries, or you are shoveling lots and lots of data in there. If you have a ratio of SQL time over Python time, which is low, it means you are spending a lot of time processing the data or sending it to a remote server and you have other network latency in there. Okay, if you have a high ratio, it means that you are spending more time fetching the data than processing it. So this also gives you a hint about where the performance is lost. And of course, you have information in the path here. You know what model is being accessed and what method is being called. You don't have the details of the request, you don't have the domain for a web search, for instance, but still it gives you a hint about what could be an issue. Okay, so we already have some information about what could be slow through the logs. Now we want to know really where the time is spent. Fortunately, since Odoo 15, and that's a blessed time, I curse every time I have to work on a 14 or earlier instance because I lack this. There are alternatives for that, but they are less good. I mean, the profiler is the best thing since sliced bread in Odoo, in my opinion. So you get a flame graph of the processing of the different HTTP requests. Okay, and you can tell which parts of the processing are actually taking time. And you get, which is something you didn't get before easily with the built-in profilers of Python, you get the details of the SQL requests which are being issued to the database. It looks like this. Okay, and so from left to right you have the time, and vertically it's a stack. And this profiling works by sampling. Okay, every 100 milliseconds it takes a stack from the execution of Odoo and records all the calls being made. Okay, and then display that as a graph. This view is interactive. Okay, you can click on a node and you will get here the detail of the stack with, no, it's probably not very readable here, but with the path of the file and the line number. And with that, you are normally quite good. And here I selected a SQL node, and you see you have here the SQL query being run. And you can then use the tools I will talk about a bit later to analyze it. So that's pretty good. And you can see some patterns. So if you have one big block with nothing under it, which lasts for a long time, you know that you have a pure Python processing which is taking super long. Okay. If you have lots of lines going down, typically at the bottom of each line there's a SQL query, you know that you have a loop and you have SQL query for each iteration of the loop. Okay, and this is probably not optimal, and we'll see how we can work about that. And you also see the different parts of the query. Okay, especially at the end, you have the recompute. Okay, and that's because when you process an HTTP request in Odoo in recent versions, it's been a while now, Odoo tries to work in memory as much as possible. So typically, you will have at the beginning a loading of data with some SQL requests, then in-memory processing of the records, and at the end, a flush and a recomputation of the computed stored fields. That's a generic pattern in your in your Odoo calls. Sometimes you will have flush in the middle because someone is making a search and you need to flush before searching. But that's also a place where Odoo is improving by not flushing too often, or flushing only what needs to be flushed in order to be able to make a search call. And there's some really smart code in there. So that's also why you gain just by upgrading Odoo, just by, if only. Okay, but that's a pattern. Okay, it also means that it's a bit harder to understand why some things are happening, because they are not happening straight away after you wrote on a field. You get the recomputation of a field which has a dependency in that field. You get it only if you read the computed field, in which case Odoo knows that the value needs to be recomputed because one of the dependencies has been modified, and then it will recompute there. But otherwise, it's at the end, and it makes harder to understand why a recomputation, an expensive one, if you're looking for it, it has to be an expensive one, is being done. So yeah, that's a drawback of the optimization. Something I learned very recently, and I wish I'd known it earlier, so I'm sharing. You can use the profiler from Odoo shell. Okay, there's a context manager. You say with profiler record.do something. Okay, and this will produce a stack call in the database, and you can view that from the user interface of Odoo. This also, I'm a little bit ashamed of saying it, it works in prod. You don't have to work on a local copy. If you have a shell access on your production server, you can just enable that for this one call and not have the negative impact of enabling the profiler on your production, and be able to debug only one action. And that's very nice also. In the same vein, one tool that I like is the SQL debug logs of Odoo. But if you enable that from the command line and start Odoo with Odoo -- log level equals debug_SQL, you get a mouthful, and more than that, of logs. Okay, you can say with self.env.cr.enable logging and run your statement, and you will get only the SQL logs issued from the processing of that statement, which is also nice and allows you to figure out things better to understand why that method is slow. In interactive mode, beware of the record set cache, because here, that's for you. If you run the same method twice, if you don't invalidate the cache, that like I did in the first line here, you may have cache records in that in the record set, and then the SQL queries will not be run again. Tough luck. Yes?
The previous one on the profiler, do you still need to commit?
No. The commit is done in a separate transaction, so you can safely roll back, especially in production. Or you can just exit, but the profile has been saved. You need to enable debugging. If you use the profiler in Odoo, it's a two-step process, so you need to enable it first, and then you can access the profile. But you don't have to do the second enablement, which has impact on the speed of the instance.
With typing this in the shell,
Yep.
it will commit to the database.
The profile is committed to the database, but not the consequence of the method. It's a separate cursor. Explain. So you have your SQL queries because you've run with SQL debug, or you got them from the profiling, okay, and you want to understand what is happening there. So that's the safe version with so you open your PSQL shell, you begin, explain, analyze, verbose your SQL statement, and you roll back. You don't have to do the begin and roll back if it's only a select. But if your statement is an update or an insert or a delete, and you're in production, trust me, you want to roll back. Okay, and this gives you a short or longer screen of explanations. That's typically hard to parse. I struggle every time because, well, I guess experts are able to read that and say, "Hello, it's here." I need a tool. And friends in a French company called Dalibo have published a tool called explain.dalibo.com, in which you can pass your SQL query and the plan returned by explain analyze. And it gives you a nice graph like that, saying, okay, here you had a sequential scan, so a full table scan of table sale order. Okay, that's expensive, and maybe we could avoid that if we had an index, which would speed things up. And it's also returning a lot of data, and the amount of rows being shoveled is materialized by the size of the path here. And you get a visual impression of where the time is spent, what are the inefficient nodes, and you can expand these, and you get information about the filter that's applied. So because typically you will have a sequential sec scan or an index scan plus a filter, okay, because it will find the rows matching a criteria based on the index, and then a filter on these nodes based on the conditions in your where statement. Okay. That's one. Yeah, that's quite frustrating. But when I run things on my computer, it's super fast. I can't reproduce locally. Let's close the issue. Yeah, well, several things could be here. You may be using a different version of PostgreSQL. I said Odoo 18 is faster than Odoo 16. That's true. PostgreSQL 16 is faster than PostgreSQL 12. So if you can upgrade your PostgreSQL cluster, run on the recent versions, and you will get speedups for free. Okay, that's quite nice. Second thing, when you copy a database, you're not getting the same layout of rows that than you had in the original database. And one thing that I've been reading about recently is table bloat. Table bloat is what you get when so the rows, the data in PostgreSQL are organized by pages. And these pages are, well, 8 kilobytes. When you delete a row or when you modify a row, the row is marked as dirty in the page, and a new row is created. And in the end, it's like the good old fragmentation tool on Windows 95 for the old timers. You get holes in your pages. And PostgreSQL will not insert a row in a hole. It inserts at the end because that's fast. Okay, so there's an auto vacuum in recent versions of PostgreSQL, but it's still not enough to recover all the space. If you have lots of concurrent access on your table, if you have lots of deletions, if you have rollbacks, you will get holes, and you will get what's called table bloat, which is lots of pages filled with at 20%, 10%, meaning that when you want to select, you have to read 1,000 pages, which could have been stored in 10, maybe. Okay, and that takes longer, and you get slow query. But when you restore the database locally on your computer, your workstation, you get a clean table. So that's a sign that maybe you have table bloat. Table bloat is cured by vacuum full, which requires typically downtime of your Odoo. Although with recent versions can be run live, but you may have locks which will slow down your instance for some time. Yep.
It's probably worth mentioning that it depends on the restore on the method of restoring the database,
yes,
whether you gain or not. Because
yep.
you could also
if you're using, yes, so
copy everything, then you copy also the holes.
Yep. If you're using a live replica of your database, you have the holes.
Yeah.
If you're, what I was thinking about is PG dump and PG restore, exactly, which cleans up things.
And then secondly, the vacuum full process is a quite costly process.
It is.
So, it's also worth mentioning not activating it in a production database without knowing what you're doing.
That's what I said. Typically, I will have a downtime of the production server for the duration of that, just to be sure. But I had one case where the res partner table was bloated, and looking for a partner in any many-to-one took 400 milliseconds. And when you add mass mailing to that, you get something really dreadful in production.
Alex?
Yep.
You mean page dump restore is meaning less downtime?
It depends on the size of your database and on which tables are bloated. If it's just one table, it's faster to make a vacuum full.
Can you do a vacuum full on one table only?
Yes. So PG dump, PG restore can be faster than a vacuum full if all your tables are bloated. But that's a real hard downtime. There's no way of running PG dump, PG restore on with a live Odoo. Okay, and you can use a vacuum full on a single table if needed. There's a nice tool called PG Analyze with an S. It's a Brit guy who made that. Because there's also PG Analyze with a Z. Okay, it's not the same one. It's a Python tool, so you can pip install it. Okay, and there's several diagnoses that it can run. For instance, there's the TBL bloat, which will list you the bloated tables. There's a IDX unused, which lists indexes that are not being used for any queries. And maybe you want to remove them because they take up space and they take up time to maintain. Okay, so we have our landscape. How do we make things a bit faster? I will need to be a bit faster if we want to have time for questions. A few faulty codes that, well, probably you know about them, but that you want to avoid in your modules and that you want to watch out for in code reviews. First one is search inside the loop. That's notably inefficient, and we'll see how we can avoid that a bit later. Be aware that sometimes the loop is not obvious. If you are using filtered, there's a loop, but you don't see it because it looks like a single line. Or you're calling another function, which is making a search inside your for loop. You have a search inside the loop. Okay, so try to move things out of your for loops as much as possible. Computed fields also can, non-stored, can cause a search inside the loop if they are not coded properly. Beware of people changing non-stored field to stored fields. That's typically a big mistake. So my first answer to a request for that is no. Sometimes that field is computed with others and you make only one of the fields stored, and you will get bad performance for that. Typically, they are non-stored because we don't want to have them stored, or they depend on the current time, or they depend on the context, or on the company, or they have very complex triggers which would make them recomputed all the time and impact the performance. So don't do that by default. On models which have lines, such as sale orders, stock pickings, be careful with a change on a line which causes a recompute on all the other lines. Okay, these are easy to miss because you won't see the performance hit when you test that with 3 lines. But when you start having several hundreds of lines in your sale order, that's a killer. Okay. In Odoo 16, there was one on sale orders if you had the delivery add-on, standard add-on installed. Okay, because it added a related field on sale order line to a field on the sale order. Okay, and you could update that field on one line, it will update it on all the lines of the sale order, and you get a super slow unchange with that. Last one is the computed field with dependencies which are triggering too often. Okay, I've seen things which are computed fields on products which have triggers on stock moves which are moving the product. And that's not good, because the moves are going to, most of the time, probably not affect the value which is computed. They are affecting a shared resource, so if you're moving several moves with the same product, you will have concurrent access, and it's globally inefficient. So yeah, that's something you want to avoid. A few things about getting the data fast. Okay, the ORM is designed, and I mean the progress they made in 16, 17, 18 is just fantastic. So kudos to the guys, Raphaël Collet and friends, working on that at Odoo. Okay, it's great. In 18, there's search fetch. And search fetch allows you to pinpoint exactly which field you are going to use in your loop. Okay, if you are passing it in a computed field which is non-stored, it's smart enough to fetch the dependencies of that field and load the cache with that, so that afterwards you are not overloading your SQL or your internal cache with too many data, but you have all the data you need to process your information. And if the data is already in the cache, it's not fetched. Yay! Yes, sir?
You said it's with Odoo 18. Isn't this like search read in the previous versions? Sounds similar.
It sounds similar. I'm not sure that search read loads the cache. Search read will return a list of dictionaries containing the fields. Search fetch returns a record set with the cache preloaded. Okay, so anytime you were using search read for optimization in previous versions, you can get really better performance with search fetch in Odoo 18. Because this comes with the with prefetch, and that was my original goal in this talk, was to learn how this works. So I learned. And my answer is, well, you almost never need it in Odoo 18. Too late. With prefetch can be used for two things. It can be used to, what it does is you take a record set, you say with prefetch and a list of IDs, and it returns a record set. And the record set is pre-configured with an internal attribute which is called _prefetch IDs, which tells Odoo which IDs it will need to prefetch when entering a loop on the record set. Okay, so by default, the prefetch IDs are the IDs in the record set, and things start mattering if you have many IDs because it's a large record set, because the prefetch is going to happen in batches of 10,000, if I'm not mistaken. So you can use it to prevent prefetching. Why would I do that? Because prefetch will be slow because I have huge amount of HTML in my columns. As I have varchar, huge text in there, and I don't want to preload that. Or I want to force a different record set to be loaded when I access my attribute. That's weird, I know. And the good thing is in Odoo 18, things are pre-configured. I think in 17 it started pre-configured, and you rarely have to do that. Okay, let's have an example. So here I have a read group call. Okay, I'm grouping sale order lines by product. Okay, and I get product ID and a list of sale order lines which contain that field. I don't have to do anything if I process things by saying for product, say line IDs in groups, okay, the value returned here, and I do something on my sale order lines. Why? Because in 17 and 18, the products that I get in groups and the sale lines that I get in groups have a prefetch ID which is organized so that if I loop over it like this, it's going to load the data in the correct order. Okay, especially the sale line IDs have a prefetch IDs, which is the sale line IDs in the order of the groups. So that when here it preloads my first sale line, it will preload the sale lines of the first group and maybe the second, third group in the correct order, and it won't have to remake the query again. However, if I change the order of the groups, I'm fucked. Okay? Because the preload is not going to happen, the prefetch is not going to happen in the correct order, and that's one case where you want to use the with prefetch and reuse the same order. So for instance, if you are after that processing the groups by the number of sale IDs, okay, you get an issue in there. Okay, and if you are not processing things in the correct order, you see that in the profiler because you have all these spiky lines. I'm a bit short on time. I can't show you that, but if you come to me, I can show you on a live instance. Final tips. Your database is also something you want to take care about when you design your modules. Okay, so first tip is think before adding new fields to a table, new columns to a table. We already have dozens and dozens of columns on tables. Okay, there is one rule in PostgreSQL which says a single row have to fit at least on a single page. So if you have too many rows and that exceeds 8 kilobytes for storage, okay, it will be, some of these will be moved to the toast table, okay, or you won't be able to fit as many rows as you want in a single page, and it will make your queries slower. So maybe think about partitioning your data and in separate pages, separate tables to speed things up. Test if your indexes are used by searches. Okay, that's an important one because adding an index has a cost when inserting and updating. So you want to make sure that your index are meaningful. One kind of meaningful index is an index on a foreign table, a foreign key, if you are going to delete the records. Because there will be an undelete trigger, and if that undelete trigger has to do a full table scan to set null the rows referencing your table, you will have something super slow at that stage. Okay, I said I wouldn't talk about concurrency, but this one is also super important when you design your model. You want to be extra super careful when if there is a chance that several people are going to update the same record at the same time, and that could be indirect. Okay, I mentioned a product with a computed field triggered by change on stock moves on that product. Okay, I've seen that not on products, on reordering rules, but that's the same. Okay, and this will trigger concurrency issues and retries and slowdown and pain and complaints. So try a different approach for that. Sometimes you have to be smart. And fortunately, there's a super smart example in Odoo, and that's the handling of stock quants, which are inherently shared resources because you want to have several people reserving the same quant at the same time. And they are doing nice things with locks. And again, that's something I discussed in a previous talk at Odoo XP, and we can have a talk about that if you want. But select for update, for no key update, skip locked is your new mantra for that. Final word about database indexes. An update can speed up a select, not always. Okay, but maintaining the updates will slow down inserts, updates, and deletes. Okay, so be aware of that, and don't add indexes which are not used, or test if they are used and remove them if they are not. If you have to, unless you have to search for nulls, use index equal B3 not null on your many-to-one fields. And you will save space, especially in large tables, by not creating entries for nulls in there. And 2 notes about the PostgreSQL optimizer. Okay, the optimizer will use an index if it thinks that the index is discriminant. So it has statistics about the values on the column. Okay, and it typically won't use an index if a value, the value that you're searching for, matches more than about 30% of the rows in the table. Okay, I don't remember the exact figure. It can depend on the PostgreSQL version, but that's the order of magnitude. So if you have 2 companies in your database and about 50% of the rows on each company for your sale orders, a search on company ID equals 1 will not use the index on company ID. It will do a full table scan, or it will use a different index which is more discriminant for your search. Same thing for searches on state. Okay, and also something you want to be aware of is that state not in done cancel will not use an index on the column state. Not in is not used, what prevents the PostgreSQL optimizer from using an index on that column. So you want to have the positive version and not forget sent in your list of states. Yeah, don't be lazy. Use in as much as possible if it gets critical for you to use the index. Knowing that if you're looking for, I don't know, things which are done and 90% of the things are done, well, it won't use the index because it's more than 30%. That index is only meaningful if you're looking for rare things. Just to finish, I'm late, sorry. A few bookmarks. These are super interesting talks from last year's Odoo XP. Probably these slides will be shared on the OCA, so you'll have the links. But these are really nice talks. I encourage you to watch them. I learned tons of things in there, and some of which are in this talk, and a little bit of the content is mine. I stole a lot of things. Not sure if we still have time for questions. 5 minutes. 5 minutes?
Thanks. You talked about the. Does it work? Yeah. You talked about the fact that we don't want to store a related field at one time.
Not quite. You want to be careful if you have maybe a sale order and sale order lines, and you have a stored field of your sale order lines, which is related to a field on the sale order.
That's it.
Yeah.
So how about if we need to put a filter on that field in a report or something? I think there's another method to.
So in 18, you can search on a related non-stored field.
18.
So upgrade.
18. It comes at 18.
Yep. Or you can make it computed and not have the unchanged trigger every time.
Okay, understood.
Or you can add another field for that.
Yesterday we talked about monitoring logs. I think it's a good thing to be proactive and see errors before the client tell us. Do you have any tip, maybe dashboard Grafana to share to monitor werkzeug logs?
I don't.
Okay.
We have Grafana and Loki at Camptocamp. There are some alerts, but there are so many false positives I mean, logs which are logging at error level, which are actually normal conditions,
Like
that we
dashboards.
are not really using that
Okay.
for alerting. So my use of the logs, well, in my daily job at Camptocamp is forensics, or understanding why the customer is, so it's after the fact, unfortunately.
Okay. Okay, and you showed me Odoo Cloud Platform repo, so I share the information here too.
Yeah.
It's very cool. Small add-ons to improve the log.
So yeah, there's a Camptocamp Odoo Cloud Platform add-ons repository on GitHub, and there are, well, maybe we should refactor things a little bit, but there are two useful things that we are adding. First one is logging the UID of the user performing a request, which can be quite nice. And a second add-on which injects in the request a UID, a unique identifier for the request. And that UID is logged in all the log statements of Odoo, meaning we can track, if we have the werkzeug log, we know the request ID, and we can track all the other logs related to that request. And that's also nice when trying to understand what's happening, because on a heavy traffic instance, of course, you get tons of logs, and they're all mixed together, and it's sometimes hard to figure things out. And I forget that it's a specific all the time, until I reach an instance which is running on Odoo SH and doesn't have these. Well, thanks, everyone.